today's lesson, we're going to be talking about how to use trigonometry to find the area of various figures. For example, if you're not given all of the links that you need for the formula, we can use trig to help us find some of those links. As a start, let's review our trig functions. The sine function, you will recall, is opposite over hypotenuse. The cosine function is adjacent over hypotenuse. And the tangent function is opposite over adjacent. If you didn't recall those from the previous chapters, you will certainly need to learn them in order to be successful with this section. How we use these to find the area of a regular polygon. Here I have a nonagon with 10 centimeter sides. Now you recall, in order to find the area of a regular polygon, it is 1/2 times the apothem times the perimeter. Now we can find the perimeter because there are 9 sides and they're each 10 centimeters, but I don't know this length of the apothem. This is where the trig comes in. First we need to find the measure of this angle. I start by finding the measure of angle PCR by doing 360 divided by 9, since there are 9 sides. When I do that, I get a measure of 40. This angle is half of that, so that means that angle is 20 degrees. Now, one of the things that we can use to help us find this apothem is this length right here. It's half of the side length, so that distance is 5. I'm looking for the apothem, which is my adjacent side. I have the opposite side, so I can say the tangent of 20 degrees is the opposite, which is 5, over the adjacent, which is my apothem. If I multiply both sides by a, I get a times the tangent of 20 equals 5. Divide by the tangent of 20, and a is 5 divided by the tangent of 20. So now I can use this in my formula. So I have 1/2 times my a, which is 5 divided by the tangent of 20, times the perimeter, which is 9 sides, times 10 centimeters per side. I then put all of this in my calculator, and I'm going to round it to the nearest hundredth. And for my answer, I get 618.18 centimeters square. In this example, we're looking for the area of a regular pentagon with 4-inch sides. So if I draw a pentagon, doesn't have to be a perfect pentagon, we're just going to pretend like it is, and I draw in my triangle of interest. I know that each side is 4 inches, so this part right here is 2 inches. I'm still looking for my apothem, so again I'm going to use tangent, but I need to find this angle right here. To find the whole thing, I do 360 divided by 5. When I do that, I get 72. Take half of that, this angle is 36 degrees. So the tangent of 36 degrees is the opposite side over the adjacent side. Multiply both sides by a, I get tangent, or a times tangent of 36 equals 2. Divide both sides by the tangent of 36, and our apothem is 2 divided by the tangent of 36. I take that into my formula of 1/2 times the apothem times the perimeter, and I get 1/2 times 2 divided by the tangent of 36 times my perimeter, which is 5 sides, times 4 inches per side. I put that into my calculator, round to the nearest hundredth, and I get 68.82. My unit is inches squared. Now, it may not ask you to round to the nearest hundredth. It may instead ask you to round to the nearest tenth or the nearest whole number, but that's easy enough to do once we have our answer in our calculator. In this example, we have an octagon. The standard size has a 16.2-inch radius. So if I take my stop sign and I draw in one of the triangles that I'm interested in, right? And here's my apothem. It tells me that the radius is 16.2 inches. So that's actually a hypotenuse. I need a side length and I need the apothem. So I'm actually going to use trig twice. We're going to start again by finding the angle measure here. We do that by doing 360 divided by 8, and then we're going to take half of that. That is 45. Half of that would make this angle 22.5. Now I need my opposite side and my adjacent side, so I'm going to use both sine and cosine. If we start with sine, the sine of 22.5 is the opposite side, which I will call x, over the hypotenuse, which is 16.2. So x equals 16.2 times the sine of 22.5. Now keep in mind, x is this distance here. So the whole side length is 2 of those, or 2x. And the perimeter would be that times the number of sides, or 8. So we need to keep that in mind when we go into our formula. To find the length of the apothem, which I'm going to call a, we're going to use cosine. So the cosine of 22.5 is adjacent over hypotenuse. Multiply both sides by 16.2, and we get 16.2 times the cosine of 22.5 equals the apothem. And now we go to our formula, 1/2 times the apothem times the perimeter. So 1/2 times my apothem, which is 16.2 times the cosine of 22.5, and I'm going to do that times the perimeter. Now this is my perimeter here, so we're going to have times 8 times 2 times my value of x, which is 16.2 sine of 22.5. Now we're going to put all of this in our calculator. We want to be careful that we get the multiplication in there correctly and we know which angles we're taking sine and cosine of. When I put it in the calculator, I get 742.29, but this asks for it to the nearest square inch. So we have 742 square inches. For our next problem, we're going to look at how we find the area of a triangle if we don't know the height. In this scenario, all I know is B, which could be the base. I know the measure of side C, and I know the measure of angle A, but I don't know the height. Now we can use some trigonometry in this, because if I think of A, and I take the sine of angle A, that is the height of the triangle over the hypotenuse of this little triangle, so over C. So the height of my triangle is actually C times the sine of angle A. So if I go back to my formula, which is the area is 1/2 base times height, so we have 1/2 times the base times the height, which is this here, so C times sine of A. This becomes another formula that we can use to help us find the area of a triangle. But keep in mind, you have to have the included angle. It doesn't matter which two sides you have, but the angle must be the included angle. Otherwise, it won't work. All right, so let's look at some examples. This is the formula up here again, so you can see that. For number 4, we're going to find the area of this triangle, so we're going to use our new formula. 1/2 times B times C times the sine of angle A. So if we plug in the values that we have, it doesn't matter which one we consider B and which one we consider C. So we're going to have 1/2 times 21 times 12 times the sine of angle A. Now again, we put this into our calculator, and we're going to round this one to the nearest square centimeter. When I put it into my calculator, I get 93.64. So that rounds to 94 square centimeters, to the nearest square centimeter. For our next example, we're going to use the same thing. Again, area equals 1/2 times B times C times the sine of the included angle, so angle A. So we have 1/2 times B, which I'm going to call 16. I'm going to call C 10, sine of 34. All right, it wants this one to the nearest square inch. So when I put this into my calculator, I get 42.326. Round that to the nearest square inch, I get 42 square inches. Okay. Very straightforward. So as we finish up, let's review the formulas that we have. Hopefully you're learning most of these, but in case you're not, here they are again. For the area of a parallelogram, we have base times height. For the area of a triangle, we traditionally use 1/2 base times height, but now we've learned a second formula, so we have 1/2 times b times c times the sine of the included angle. For a trapezoid, the area is 1/2 times the height times the sum of the two bases. For a rhombus, you will recall we're using the diagonals. It's 1/2 times the product of the two diagonals, so everything gets multiplied. A kite has the same formula as a rhombus, so it is 1/2 times diagonal 1 times diagonal 2. And for a regular polygon, we have 1/2 times the apothem times the perimeter. And remember, to find the perimeter, you simply take the number of sides and multiply that by the side length. So it becomes very simple. I hope you've enjoyed this lesson today, and I'll see you in class.